Hey there everybody, my name is Chili and welcome to my 3D Fundamentals series. This series is going to teach you the principles that underlie all real-time 3D graphics. I'm here to peel back the veil of mystery that surrounds 3D graphics and how it actually works. If you're looking for just some code to copy and paste so you can cobble together something you don't even really understand, you've come to the wrong place. We're in the knowledge business here. And the knowledge you learn here will apply whether you want to create your own custom 3D engine based on Direct3D or OpenGL, or use a pre-made engine like Unreal Engine or Unity. Now, the thing about hardware-accelerated graphics is you have full control over some parts of it, like the pixel shader, the vertex shader, etc. But other parts are mysterious black boxes, like the rasterizer, the clipping, the culling, the perspective divide, so on and so forth. And for this reason, it can be hard to wrap your head around the full picture of 3D graphics. Constructing every part of the engine ourselves will give you deep understanding of the entire 3D graphics pipeline, without all the hidden black box portions of Direct3D or OpenGL. Then, once we have this knowledge under our belt, we can apply it to creating an engine in Direct3D in the next series. This is a pretty unique approach you won't find anywhere else on YouTube. In fact, most of my research preparing for this series kept turning up things like lecture slides from master degree university courses. So we're going to be exploring what is effectively a graduate school level subject. Now that sounds pretty cool, but don't let it intimidate you. There's going to be math, but it's far from the worst I've seen. If you're prepared to give the ideas some thought and actually try to wrap your head around them, they can be readily mastered. And mastery will make 3D your bitch, rather than the other way around. Alright, let's see what's on the menu. This introduction video is going to list the prerequisites of what knowledge you need and what software you need to follow along. Next video, we're going to do a brief tour of the starting code and set the stage so we make sure that we're all on the same page. Then, starting from video 2, which is the third video because real programmers count from 0, we will begin our 3D journey proper. In terms of hardware and software requirements, you're going to need a video card that supports at least Direct3D 9, a Windows operating system at least version 7 or later. You're going to need Visual Studio Community 2015 or later. And you're going to need the starting code, which is based on the Chili framework. Now, every video in this tutorial series is going to have its own wiki page, and those wiki pages will contain links to any material you need for the particular lesson, and any other useful information. Now, the tutorial code itself is going to be made available via GitHub, and you can find the link to the GitHub repository on the wiki page. And what I'm probably going to do is use branches to mark out specific points in the evolution of the engine as we create it. Alright, let's talk about prerequisites. This series fits into the bigger picture of the Planet Chili tutorial program, and you need to know the material covered in the preceding series to be able to follow along here. Now that doesn't mean you need to watch all those videos, but if you don't already have the required skills, you're going to have to get them from somewhere. So what do you need to know? First off, this is a 3D theory course, not a C++ course. I'm not teaching anything about the C++ language here. You should have that shit sorted by now. Specifically, you should know about basic control and data like arrays, pointers, loops, all that jazz. You should be familiar with classes, special functions, operator overloading, virtual functions, inheritance, and templates. You should know some sexy C++11 stuffs like move semantics, lambdas, uniform initialization. And you should be familiar with the standard template library, specifically, containers like vector, things like unique pointer, and working with iterators. Now, I will be teaching many math concepts here, but you should already have a firm grounding in two-dimensional math. You should have 2D vector math down pretty hard, dot product, shit like that. You should be familiar with your standard transformations, especially rotation. You should be comfortable with the matrix representations of these transformations. You need to understand linear equations, stuff like alpha blending or drawing a straight line. And you should be able to manipulate fairly simple equations and formulas. Now, as far as graphics goes, I'm going to expect that you understand how the general raster works, how pixels are composed and how they're organized on screen and in memory. I expect you understand at least one algorithm for drawing straight lines, and it would help a lot if you already understood how to draw about solid triangles and 2D textured triangles. I'm probably going to review triangle rasterization in this series, but I'll also give a link to videos where I give a more detailed description. And last but not least, you're going to need basic GitHub skills in order to, get the code and interact with it. Now, this isn't a comprehensive list of everything you need to know, but I think it gives you a general idea. If there's just a handful of things you're not sure about, you can probably figure them out as we go along with the help of Google and the wiki, and level up your programming chops a bit. Either way, feel free to check out these 3D videos and decide for yourself. Just don't get all pissy in the comments if you find out that you're out of your league here. Man up and get good instead. I've got tons of material here you can use to get up to speed. And there's always the Google machine. And I'll also try to get up a collection of info on the wiki for preparatory study and review purposes. But if there's a ton of shit here that you don't know what the fuck, then you probably need to look at my earlier tutorials. This series will focus on fundamental concepts, not prettiness or speed. And we're going to stop when we get the basics down, because we want to move on to hardware accelerated development as soon as possible. Here's a brief tentative outline of the topics. They're probably going to change somewhat over the course of this series. We're going to start off with the basics of 3D space and transformations. Then we'll move on to triangle rasterization techniques in a 3D correct manner. Then comes lighting and shading, and at the end we'll look at topics like clipping, projection transform, homogeneous coordinates, and camera motion in a large scene. Now, the software architecture of our system is going to mimic the hardware pipeline as much as possible. We'll also choose conventions, for example, right-handed coordinate system versus left-hand coordinate system, that match those of Direct3D. Although the ideas will apply equally to OpenGL, just with minor changes. The idea here is by creating such a system that mimics the hardware pipeline as close as possible, it'll make it that much easier once we do the transition over to hardware 3D. And that'll about do it for this intro video. I hope it gave you a good idea of what this series is going to be all about. And if it sounds interesting to you and you want to see me make more videos on this topic, please hit the like button. It means so much for the first video in a series like this. Either way, thanks for watching, and I'll see you soon with some more 3D fundamentals.